Hello again, College Algebra. I'm trying something a little different right now. Instead of recording at school, I'm recording at home, so just bear with me. I'll try to edit out any interruptions I may get from my children because they are here with me. Anyway, in this, we're doing Chapter 1, Section 4. It's all about quadratic equations. So we're going to be solving quadratic equations, and we're going to be solving it using factoring and the zero product property, the square root property, and also by what's stated here, completing the square and the quadratic formula. So basically everything that you learned in one chapter in Algebra 2, we're going to be doing it in one section here. So just bear with me, like I said, and we'll get through it. So, quadratic equation in one variable. Here is how it is written. Ax squared plus bx plus c is equal to 0. This right here is our quadratic, and that is known as the standard form of our quadratic equation. Before we solve anything, the majority of the time, we're going to be putting it in standard form, especially when we go to factoring or the quadratic formula. Okay? A quadratic equation is known as a second degree equation. That is an equation with a squared variable term and no terms of greater degree. So this right here is a squared term, and there is no degree higher than 2. And that is what a quadratic is. Zero factor property. What this is whenever we're going to be using this in our section here, what we're going to be doing is factoring out our quadratic like we have learned previously in algebra. So when we factor a quadratic, we factor it out into two linear factors, meaning this right here. Say we have a quadratic that factors out into, let's try that again. Let's see, something like, yeah, I had that right. Ax plus b times cx plus d. Say those are our two linear factors that our quadratic factored out to. What this zero factor property states is a way to solve for our x values is, now that we've got it out in factored form, is we're going to set this set of parentheses equal to 0, and then this one also equal to 0, and we end up with two solutions to our equation. So let's use that property. So first thing, factor this quadratic. If you can't remember factoring, so if you don't remember factoring, this is the way we're going to do it. Remember, we're going to break it out into two sets of parentheses, two linear factors, and set it equal to 0. In one set of parentheses, we're going to have an x and then the other an x. That's going to be our first term. And then what goes here is going to come from this right here and our middle term, the 3x. What we have to do is find two factors of negative 18 that add up to 3, our middle term 3. And what I see is 6 and 3. And it has to, these two have to multiply to negative 18. So one of these numbers is negative, one of them is positive. Since we have a 3x here that's positive, I'm going to put my plus sign on the 6 and the minus sign on 3. And we're done. Factoring, that is. Now to solve for our x values, using that zero factor property, we're going to take x plus 6, set it equal to 0, and x minus 3, set that equal to 0, and for both cases, solve for x. So here we get x is equal to -6, and on this other one we get x is equal to 3. That is our solution. For this, like in the first section, you were asked to find the solution set. The solution set for this would end up you would write this. So solution set are our two values that we just solved for, x equal to -6 and 3. So just put in your set of brackets, -6 and 3. And that's it. Now we have solved our equation and found the solution set. Alright, we're going to again use the zero factor property on this one, but this one's just a little bit more difficult because there's more steps involved. And the reason there's more steps involved is because of this 10 right here. In our previous one, our coefficient on our x squared term was 1. This time, it's 10. And I'm going to show you a method called the Berry method that I'm pretty sure most of you have seen before. So, here it goes. In the Berry method, what we do is we're going to break it out into two sets of parentheses, and instead of x and x in our parentheses, we're going to say a 10x and a 10x. Okay? Then the next step of what I'm going to do to get these two values right here, just like before, we used our last term and our middle term to come up with the numbers that go in the set of parentheses next that you see underlined in red. And using this Berry method, what we're going to do is take our first term, or our first terms, the coefficient on our first term, and then this constant term, multiply those two together. So we end up with -20. And now the two numbers that we're looking for that's going to go in this underlined portion that I have in red is two factors of -20 that add up to be +1, because it's understood to be 1 right here. And that is going to be -5, or sorry, no, +5, and -4. And that's what goes in these spots here. Because we want that middle term to be a +1. Our 5 minus 4, that's why we use -4 instead of a -5. Sorry for that little mistake there. But then we keep going. If I asked you to factor this properly here, the next step would be to factor out any common factors you see in the entire set of parentheses here, and then just throw those numbers out. But since we are solving an equation, we don't necessarily have to do that. All we have to do is set our what we have in our two sets of parentheses, both equal to 0, and solve for x in both of our cases. And that is what I'm doing here. Okay, so solve for x, we get let's see, x is equal to -1/2, and then On this side, this other one, we get our x is equal to a positive 2/5. Because 4 divided by 10 reduces to 2/5. And there's our two solutions. And our solution set. That ends up being our two values that we just found. Negative 1/2 and 2/5. And there you go. That's using the Berry method along with the zero factor property that we're learning. Square root property. All this states is if you have a x squared equal to some number, what your solution is going to end up being is one's going to be the square root, the positive square root of that number, and then the negative square root of that number. Okay. Let's use it in an example. Here we go. It says solve each quadratic equation. We're going to be using the square root property in all three of these cases here. So, first step, what we do is take the square root of both sides of our equation. And make sure that square root property gets properly used, because x is equal to not just the positive square root of 29, but the plus and minus square root of 29. These are two separate solutions. One is positive square root of 29, one is the negative square root of 29, but we can write it just like this, plus or minus the square root of 29. Okay, next one. Here we go. Take the square root of both sides, and we're taking a square root of a negative number. Told you in the last section, we'll see imaginary numbers in this one. And that's where we're coming to imaginary numbers. So x is equal to, and then square root of a negative, we're going to end up tagging on the I to the end of this solution. So we get plus or minus, and the square root of 144 is 12, so we get plus or minus 12i. Next, we end up in part C here, we're going to be using, again, this square root property. So the first thing we do in part C is we're going to, just like in the previous problems, A and B, we took the square root of both sides of the equation to get rid of that squared. So now we have x minus 8 on this side of the equation, because the square root of something squared is just whatever you have inside the square root and the square. And that's equal to plus and minus, don't forget that, the square root of 24. And let's go ahead and put the generos, we're going to put negative 24 in different, we're going to simplify that. Let's simplify square root of 24 off to the side here. That breaks down into square root of 4 times 6. And so we can take the square root of 4, and that gives us 2. The square root of 24 is 2 times the square root of 6. Now I'm going to replace this for the square root of 24 now. So it's plus or minus 2 square root of 6. And now to get x by itself, we just need to add 8 to both sides of the equation, and we're done. So adding 8, we get x is equal to 8 plus or minus 2 square root of 6. And that is our solution. All right. I know a lot of you dread this one, but we're going to be asked to solve quadratic equations by completing the square. And these are the steps that we're going to follow. And on the next few slides, I have the steps already written out that we're going to follow. So let's just keep going. These steps are also in your book, so you can look those up. All right, solving using completing the square. When our value of a is equal to 1 already, we don't have to do that first step that you saw in the previous slide. So we can get down to just rewriting the equation so that the constant is alone on one side. Meaning this number right here is alone on one side of the equation. And how we do that is just simply add that constant to both sides of the equation. So we end up with this here. Now, the next step, we're going to add to both sides of the equation another term. And how we come up with this term, so we can have a complete, what's called a complete square on this side of the equation, is we take half this number here, the coefficient, put that in red, and take half that and then square it. And that's the number we add to both sides of the equation. So half of 10 gives us 5, and then that squared gives us 25. So add 25 to both sides of our equation. So again, I'm going to write that step out. I'm going to take half of 10 and square it. I'm going to add it to this side, and what you add to one side, you must add to the other. Like I said, that whole thing right here ends up being 25. Let's rewrite that. So this is 25 on this other side, on the right side of the equation also. So 20 plus 25, we have 45. The next step is going to be on the next slide. So what we're going to do in this next step is exactly what this thing says. Factor the resulting trinomial, that's what's on the left side of the equation, is a trinomial, as a perfect square, and then combine terms on the other side. Well, we did already combine the other terms on the other side of the equation. We got 45. So let's just rewrite what we had on the previous slide, and then we'll look at the factoring the resulting trinomial. Okay, so when we factor x squared plus 10x plus 25, what we should end up with, because of the way we are completing the square in this quadratic equation, on our left side here, that is known as a perfect square. Okay, so it's going to be a linear, what's inside our parentheses is linear, and it's that squared. So what I know it to be is x plus 5. If you don't believe me, we can multiply x plus 5 out, and well, x plus 5 squared out completely, just do that on your own if you want to, and you should see that it does equal x squared plus 10x plus 25. Okay? So here we go. That is equal to 45. Now we can solve for x using our square root property that we did in the previous example to solve for our solution. And we do that by taking the square root of both sides of the equation. And remember, when we do that, we end up with x plus 5 on this side, and then the plus and minus of our square root of 45. Okay. Now, again, we can break this 45 down into two different factors. So let's do that. Square root of 45. That breaks down to 9 and 5. And we can take the square root of 9, that's 3. So 3 square root of 5 is what I'm going to replace a square root of 45 with. And then to solve for x, simply subtract both sides by 5. And we have our solution. There we go. And that is completing the square. Now we're going to do another example. So let's keep going. So this is completing the square when a is not equal to 1. So our coefficient on our x squared term is not 1. It's something else other than 1. The first step we're going to do is divide both sides of the equation by our value of a, which is 4 in this case. So let's do that. Basically what you're doing is dividing everything by 4. And when you divide this side by 4, you're going to end up getting 0 anyway. So divide everything by 4. That's what we're doing. So we get x squared plus, we can go ahead and reduce that if we want to, but we don't have to, not yet. You can say 6/4 x plus 5/4 equals 0. Just like in the last step, we want to rewrite our equation in the next step with the constant alone on one side of the equation. And that's what I'm going to do next. So we've got to subtract the 5/4 from both sides. And now we're going to take this term right here, divide it by 2 or multiply it by 1/2 and square it. And we'll end up getting, let's see, what do we get? Um, 9/16 is what we should get. And we add that to both sides of our equation. Okay, let's go to the next step on the next slide. So it says factor the resulting trinomial, that's what's on the left side of the equation, and then combine terms on the other side, on the right side of the equation. So whenever we factor this resulting trinomial, I'm going to reduce that 6/4 down to 3/2 now in the previous slide. Let's go ahead and combine those two terms. Let's see, what was it? -5/4 plus 9/16. If y'all have trouble with adding fractions together, please let me know. We'll cover that in class. But that ends up being -11/16. Now the left side of this equation, we need to go ahead and factor it into its perfect square. So we have an x here. And what number goes in this spot right here comes from this. Just take the square root of that fraction there, and that will get you what you need to put in the rest of this parentheses here. So if we take the square root of 9/16, what we're going to end up with is 3/4. So x plus 3/4 all squared is equal to -11/16. Now that we have that step done, let's go to the next step. We're going to use the square root property to complete this and to complete the square and find the solution. Here we go. I'm going to rewrite what we have above real quick. Okay. So using the square root property, take the square root of both sides of the equation. And notice here on the right side we have a -11/16. We are going to have an imaginary solution here, a complex imaginary solution. But on the left side, we just end up with x plus 3/4, and that is equal to plus or minus. I'm going to go ahead and take the negative out of the square root by writing as imaginary over 11/16. Now this square root of 11/16, that can be further reduced to this. Remember the property. We can just break it up like that. And the square root of 16 is 4, so it ends up being square root 11/4. Okay? Now, let's go ahead and I'll rewrite that for what we have on the right side here in just a second. But what we can do in the next step is say add 3/4 to both sides. Or no, sorry, subtract 3/4 from both sides. And then plus or minus our I square root of 11/4. And there's our solution. Okay? That is completing the square. Hopefully that wasn't too painful for everybody. Alright, quadratic formula. Y'all may like this one a little bit better. But believe it or not, the quadratic formula that you will see on the next slide comes from completing the square from this equation right here. Ax squared plus bx plus c equal to 0. If you complete the square, which that's going to be an activity in our class after y'all watch this one day in class, we're going to complete the square of this equation using a, b, and c as our constants in our equation, and we're going to come up with the quadratic formula. So once you watch this, you may want to figure it out on your own before class starts. Here is the quadratic formula. there are several ways that you can memorize this quadratic formula. I don't require you to memorize the quadratic formula, but it is nice to have it in your memory bank rather than looking for the formula. Okay, so please at least try to find a way to memorize this. And I have a couple of different techniques. Just ask me in class. Here we go. This example, we're asked you to use the quadratic formula to solve for the solutions. And before we find the solutions using the quadratic formula, this thing needs to be in standard form. Our equation needs to be in standard form. So let's rewrite that in standard form. And the only thing that we need to do to write it in standard form is set this thing equal to 0. So subtract 3 from both sides, and we've got it. What is our A, B, and C? That's our next question. So our A is our coefficient on our x squared, which is understood to be 1. So let's write that. B is our coefficient on our x term. It's 6. And C is our constant. And we take negatives along with or minus signs along with our numbers. So don't forget that. So it's -3 for our C. And then we plug away into our quadratic formula, which I'm going to state for you. X is equal to -b plus or minus the square root b squared minus 4ac all over 2a. And now let's plug in our numbers. So -b, which is -6, plus or minus a -6 squared. That's going to give us, I'm going to go ahead and do a few steps together. B squared, 6 squared, it's going to give us 36, minus 4ac, which is 4 times 1 times -3. So that actually ends up giving us minus a -12. So minus a -12, so that's plus 12. And that's all over 2a. So 2 times a is 1, just over 2. Now, the next step in this quadratic formula is to simplify this solution further. Okay, so we're going to, let's come up here. X is equal to, so -6. Let's simplify what's in that radical. To, let's see, 36 plus 12, that gives us 48. That's all over 2. Now, 48, it does have 2 factors, in which one factor you can take the square root of. That it's going to split out to 16 and 3. Okay. That's what we're going to replace the square root of 48 with. And that is going to end up equaling, let's see, 4 square root of 3. Okay, so let's rewrite it like that. Now the last step is divide by 2, because everything in the numerator can be divisible by 2, so do that. -3 is what you end up with for the first term, plus or minus 2 square root 3. And there is our solution. Alright, again, let's use the quadratic formula. And again, let's rewrite this equation in standard form before we start figuring out what our A, B, and C is. So I'm going to subtract that 3x from both sides and add that 5 to both sides to end up with this equation. Now, let's find our A, B, and C. A is our coefficient of the x squared, so 4. B is the coefficient off of our x term, which is -3. And our C is our constant, 5. Now let's plug it into our quadratic formula. X. So, again, I'm going to go ahead and rewrite it. Write the quadratic formula out for you. The more you write out the quadratic formula, the more you get practice, and it helps you memorize it too. Okay, so B, or negative B, so -3, that's going to give us a +3. And -3 squared, that's going to give us a +9. Minus 4AC, so 4 times 5. Let's see, what does that give us? That gives us 80. That's all over 2A, so 2 times 4, which is 8. Okay, and now let's reduce what's in the radical. We're going to get -71 here. And there's not very much simplification to this problem. So we're just going to say we can take the negative out of the square root by calling it I. And 71, there's no factors of 71 that you can take out of the square root. So this is our solution right here. And we are done. In the next section, we'll be discussing some application problems, just like we did with the linear equations, and we went on to applications of linear equations. So this is just a little preview here of maybe something that we'll be doing and using in the next section. So what we're asked to do is solve for a specific variable, and here we're asked to solve for r. And you see that r is squared in our formula. So we're going to have to take the square root of both sides of the equation eventually. And when we do that, this is a little hint. We must use that plus and minus value that we've been told to use. Okay, so let's just rewrite this formula. Okay, I'm going to kind of do this in steps a little bit. First, I'm going to get rid of that 1/3. And to get rid of 1/3, I'm going to multiply both sides by 3. Multiply by 3, multiply by 3. It cancels out. So we end up with 3v is equal to pi, let's see, r squared h. Now divide both sides, get r squared by itself, because we are solving for r, but we must first get r squared by itself. So when we divide both sides by the pi h, that cancels it out from this side. Pi is canceled out, h is canceled out. and we are left with r squared by itself, and that's equal to our 3v over pi h. Now this is where we use this hint right here. I'm going to switch it around. R squared is equal to 3v pi h. Take the square root of both sides of our equation to get r all by itself. So we get r is equal to, and this is going to be plus or minus square root of 3v over pi h. And this is all I ask you to find. Do not try to simplify any further than that. That is it. Okay. So one thing I wanted you to note is in example 8, that last example, we took both positive and negative square roots of the side of that right side of the equation. But in the application problems that we'll be doing in the next section, many times we'll be representing time or a length of something that we're asked to find. And since there is no such thing as a negative length or negative time, we'll only need the positive side of the square root, and we'll just not even worry about the negative at all. And that's the only case we won't be worried about the negative portion. But we're done now, and we'll move on to the application problems of quadratic equations. So, bye.